Hi, everyone. So like she said, I'm Dan Lanthier. I'm going to be here to talk about how I got my plant to tweet. I slightly renamed my talk to something else, which is how I learned to stop worrying and tweet the plant. A tale of connecting a dying plant to the internet. So about me first, I'm Dan Lanthier. I'm an engineering manager at Macadamia Technology. We are an agency company, so that means that we build products for our customers, so whoever the customer might be. Some of our customers are Fortune 500 companies, some of our customers are startups, various types of technologies. And when we're not on projects, we try to have fun. That's one of the such projects that we just had for fun. About myself, my background, I have about 10 years experience in engineering. I graduated at University of Ottawa about 10 years ago, and since I started working, I started in the telecom industry. I worked on Windows servers, delivering voice for phone systems, did a lot of scaling and troubleshooting and quality improvements there. I moved on and worked on 2 different media syncing applications for mobile phones at BlackBerry. Afterwards, I moved to Macadamia, and at Macadamia I worked on various different projects. The largest one I worked on was for a Fortune 500 company. It was a desktop client for a unified messaging system. I've also worked on Android tablet launchers, iOS iPad applications, and more. So there's a lot of very different, varied work that we do there. And when we have fun, we work on things like the plant, like I said. So you can follow it on Twitter. It's Office Shrub, sorry. And this plant's actually special to me. I got that plant in the 1990s. My 5th grade teacher gave that plant to me. And it's been, in a constant state of neglect and disarray. So I figured might as well connect to the internet and maybe Twitter to get a bit of insight of when I need to water it. So I'm going to start with a nice quote from Mitch Hedberg, which said, "My fake plant died because I did not pretend to water it." So that's kind of my attitude with my plants normally. I really don't take care of them unless they're in my garden. So we had an opportunity to go and teach what the Internet of Things is as well. So I thought, hey, might as well connect my plant to the internet and teach what IoT is to a bunch of people. So why did I go with Twitter, though? I mean, that plant's in a constant state of disarray. I've been neglecting it for years. I figure it can't really be happy. Doesn't really have a voice, really. I need to go to it to see if it's doing very poorly. The next thing is that we're moving slowly to a mobile first world, and that plant is really stuck in the Stone Ages. And I've been treating it so bad that if it was a real person, it'd be outraged at me. It'd be really angry at it. So if we're thinking mobile outrage, having Twitter comes naturally, right? So I moved on Twitter for that. And just to give you a bit of context of what IoT is nowadays. So it's not a new thing to connect and network objects, physical objects. I mean, used to be called M2M. Probably, in the 1980s, you had MIT labs connecting their vending machine to servers. There's actually nothing super new to it. The reason it's having a kind of a renaissance nowadays is sensor prices are becoming cheaper, cloud computing is becoming cheaper, and that opens huge sorts of potential for IoT. So how about I give you a quick demo of what we built. This is the plant here, as you see. I've made the nice contraption here. We 3D printed it at work. It's a fairly simple contraption. I mean, I am a software guy, not hardware specialist, so I put a nice photoresistor on it and hygrometer to it, and with the IoT chip here. If we go down to a Twitter, we have a nice plant here with a nice tweet feed. So what it actually does is when I actually neglect it, when it gets really dry for so long, it actually tells me, hey, I need water. And when I water it, it tells me, hey, thanks for the water. And you see the tickled me is when I press a button. So if someone actually presses on it, it actually updates and says what it does. So yeah, the message is kind of suggestive. That just happened, but we can have fun, right? Like, it's just for fun. It's suggestive. It's the way it is. But the plant is feeling dark and wet right now. That's just the way it is. It's humid. We also built a nice little dashboard to go along with it that gives you a bit of insight of what's going on with the plant. Right? So the water level's good, so the hygrometer is reading nice humidity on there. The light level, we're indoors, it's not so hot. So that's kind of what the plant does. It really doesn't do a whole lot more. You can ask it questions, it might answer you. It's fairly simple. Like I said, the purpose of this was to build something educational, and what I want to share is how I went along to do it. So let's move on to the next slide. So, the most interesting thing for us as, me, especially me as a software engineer, is to pick the right hardware. I really don't know what the right hardware is for this sort of stuff. But what I do care about is to have hardware that lets me get the most of my software knowledge. So there's a lot of options, right? IoT is huge. It's kind of in a Wild West sort of phase right now with in regards to what options you have. It's not unlike what mobile was about 10, 15 years ago. A lot of different players, a lot of different platforms, a lot of different technologies involved. That's where IoT is. The reason for that is that all the big companies are starting to see huge potential there. I'll go over some of the options here. So the biggest one that I see upcoming is Google Brilio. They have been fairly light on detail for it. It's an invite-only request, but it is an Android-based system. So a lot of potential if Google is putting their money behind it and leveraging some of the technology they've made for other platforms like Android TV, Android Car, and things like that to back that Brilio platform. The Raspberry Pi is a kind of an obvious and classic one. I didn't choose that one for this project. It's overkill. It's way too much for what I'm trying to accomplish. You can run full operating systems on that. You don't need that for a tweeting plant. Same thing with the BeagleBone Black. It is another system on a chip. That one runs full Android. Overkill might be required for some projects, but for a simple thing, a simple circuit that doesn't need too much computing power, completely overkill, so I didn't go with that one. The Tesla is another platform that is surfacing up. They're at the version 2. It's fully open source. The hardware, the software is open source. It is really geared towards software developers first. The reason for that one is that instead of plugging sensors, the way I've done it that way is that they have modular sensors. So you just buy a chip that you actually plug in the microcontroller, and then you get access to nice modular hardware that you can put on in there. So you don't really have to worry about the circuits all that much. Again, it's more for the fun of it. That could have been a viable platform for what I accomplished there. There's Pinocchio as well, which is a Kickstarter. That one's Arduino based, and what it does is actually, the big difference with that one is that it does a mesh network. So you have one of the Pinocchios that acts as a master in the system. It connects to Wi-Fi, and if you have other of these microcontrollers, well, they connect to each other, down to the master, and down to the Wi-Fi that way. So that's a bit interesting. It actually, if you think of applications where you could go put it outside, you might have a bit of wireless extension there. But I didn't go with any of these. So my top 3 contenders were, Firefox. Firefox actually started to move down that road. So they actually announced 2 weeks ago that they were discontinuing Firefox OS for their phones, but they're actually interested in bringing it for IoT. So lots of players. But the big one, the big classic one, is the Arduino. So I really looked into the Arduino for this project. It's kind of the classic one. It got started by a bunch of engineers in Italy. They open sourced their hardware, they open sourced their software. And what they actually did with that one was to basically jumpstart the the IoT revolution, right? And it's kind of funny because that doesn't have a Wi-Fi chip out of the box, but it's still what actually started everything. If you've never played with it on Arduino, it's actually fairly straightforward. There's shields that you can put on top of it. So say you want a shield of weather sensing sensors. You just put it on top and it just plugs in. There's documentation. That is by far the platform that has the most documentation. So if you're looking at something where it's well documented, you're ready to go, that might be a good one. However, there's no Wi-Fi connectivity out of the box, so you might want to try something else. So I looked at the Particle afterwards. So that's a big one. It's up and coming. There's actually, that one actually is Arduino based, so any code that you write for Arduino actually works on that one. That's good. They are also open sourcing their software hardware. That's also good. The big difference is that it also comes out with internet connectivity out of the box. So they have Bluetooth, they have Wi-Fi, and they're coming up with the Electron very soon, which will connect to 3G. So you have a small device you can just buy on the internet for like 20 bucks that you plug in, you put some power in it, and it goes and connects to the internet, and you can run some code on it. That's pretty awesome, right? And on top of it, they give you a cloud platform, a cloud piece to it. So you actually can go and code RESTful services directly on the chip, and it deploys it to their cloud automatically. They're pretty constrained, but it's a huge advantage. You don't have to have your own server in that case. We'll go a bit over that a bit later. The other one I looked at was the Electric Imp. That one is fairly similar to the Particle in the way that it comes with cloud computing power out of the box. The form factor, however, is completely different. It is an SD card-like platform. So the actual SD card you see on the slide is where all the microcontroller, the Wi-Fi chip, everything's contained in there. And the other board, it just contains an identifier and some pins, right? And some options to power it. So if you think about it, when you're quick prototyping, if you fry your board, the only thing you need to do is swap the SD card and you keep going. The IDs don't change. It's tied to the actual small April board that they call, that contains the holder for the SD card. So what you can do in that case is, if you're not like if you're actually prototyping on it and you fry your hardware, you do some key mistakes, it's actually very easy to just swap another one. You just have tons of SD cards in your drawer, and you can just swap it around and move on. So the other interesting piece with that one is that while the other ones run C or C-like languages, this one actually runs Squirrel, which, if you haven't heard about Squirrel, it's a language that kind of reminds you of JavaScript. It's not exactly like JavaScript, but if you've done JavaScript, you'll find yourself right at home with that one. So, like I said, there's a lot of options. There's no true winner right now. If you're looking at doing a fun project, the true winner is the one that you feel the most comfortable with, the one you actually want to learn more about, and the one that actually gives you what you need, right? So it's really up to you. I've done project with the Particle before as well, for fun. I found it was a great platform, but I wanted to learn something else, and I wanted to try a platform with higher level language, so I went with the Electric Imp, and really, it made me feel all warm and fuzzy inside like this cat. So that's why I went with that one. So let's go over what I actually need in terms of hardware. So what you actually need is a breadboard. That's where you'll plug your pins in. I don't know how familiar you are with hardware, but I'll go over it anyway. A couple of resistors as well. One LED. That LED just basically tells me the state of my device, see if it's connected online, see if something's happening in there. It's kind of a good way to troubleshoot when access to the actual programming tools. If you see the device, it's not blinking right now, but I don't know what's going on, but it kind of gives you a good idea of what's going on. LEDs are also likely the first IoT project you'll do if you're actually interested in doing one, because you'll just get it to blink with a web service, right? The other one I used is a photoresistor, like I mentioned a bit earlier. Basically, that one goes into a pin on the board, and the more light it gets, the more resistance it offers, and the less current goes to the pin, which means that you get different readings on the actual pin of the microcontroller. Hygrometer, again, I can actually show you what it looks like. So it is this two-pronged device here, and how it works is that it injects current on one end and reads what goes through the other. So the more water, the more humidity there is, water being a conductor, the more electricity goes through. So, and the chip goes and reads that reading afterwards. So these are the two main ones. If I were to build a real product, a real thing for that, it'd probably be on the plant itself. I'd probably have different arrays, right? But for the purposes of, teaching people what IoT is, I'd prefer to stick to something simple, which this is. I also had a push button to get the plant to tweet itself, in case people were interested to make it tweet. So, what about the software? I mean, a lot of really the most interesting thing, what makes IoT nowadays, is that the software is becoming more and more accessible. So what about the software? What does it look like on Electric Imp? So first thing first though, how do I connect that to the internet? Like there's no buttons there, I can't input text in there. That's a big problem in IoT right now. How do you connect the thing to the internet? Electric Imp has a solution. They call it Blink Up. So basically what happens is that they have a nice sensor here, a sensor that reads light. And your mobile phone behaves like the Blink Up here. And what it does is it actually serializes your Wi-Fi credentials into black, white, and gray. And you bring it up there and the light sensor reads it. There's also a token to make sure that it's associated with your account. But it actually connects it to Wi-Fi. So that's actually quite ingenious. However, there's severe drawbacks to it, right? If you think about it, I'm trying to connect my thing to the internet. If that fails, that thing's not connected to the internet. So troubleshooting steps for that are actually even annoying for engineers, because what they actually give you for feedback is blinking LEDs of different colors. So you always have to go back to a reference manual to go look, what does green, yellow, yellow, green, red mean? So you have to go back there. That's the only insight you get. You don't get actually something in software telling you back that it didn't connect, because all you know is that it timed out, it didn't connect in software. So that's a bit of a drawback there. Other companies are coming up with different solutions. So Google is coming out with their Weave protocol. So they bought Nest with the learning thermostat last year. The Weave protocol is something that needs to be built in routers, needs to be supported via hardware, but it is, one of the goals is to make it mesh capable as well. And it is also, one of the goals is also to make connectivity a lot easier. And Particle, the other one I talked about earlier, their approach is to create their own Wi-Fi network, at which point you connect to the Particle from your phone, you give it the information directly in a peer-to-peer network, and then it goes and tries to connect to your hotspot. So there's a lot of different approaches. Right now, I would have to say it's just not a great experience no matter what. So really the software. So what Electric Imp gives you is a web ID. So they give you a nice web ID where you can actually program in Squirrel. So that means there's no USB, no serial, nothing like that to deal with. You just, your chip is connected online, it's connected to the cloud, you have an ID and you just code directly from the internet, and when you actually spin a build up, it actually pushes the firmware to the device automatically. That's pretty good if you think about it. I mean, if you think about how this sort of thing worked 10 years ago, you need it to be wired to your computer. Even with an Arduino, you need to do that. That's just done all instantaneously. So that's one of the bonuses of it, but one of the big drawbacks is that the IDE is kind of crude. If you're using Git, a lot of, used to collaborate in software with a lot of engineers, this is kind of lackluster. Basically, I'm sure they use Git in the background, but they don't expose it to the user. So what you actually get is just a list of builds. If you look at the build 5 in the screenshot, every time you save, it creates a new build. And that's the only change management access you have. So if you're actually collaborating, it's not a positive workflow. You either need to share accounts or work independently in 2 accounts, and then what if you have merge conflicts and things like that? Our solution has been mostly to copy paste it and add an actual proper Git repo, but it's not great for collaboration either. So it's a big drawback that they have. Electric Imp recently came out with their build API, which means that you can actually push builds from your local machine to their servers. So that might alleviate the problems as well, but the tool set's not quite ready. So a bit of a thing there. If you actually want to collaborate, it's a bit challenging. One of the other nice things that this provides you is that if you see that there's an agent side and a device side. I'll go over a bit more the code a bit later, but the agent side basically represents what that device is on the internet. It is its physical representation on the internet. The agent, the device itself, is the device, nothing else. So pins, it has no idea that it's connected to the internet. So there's great separation of responsibility there that you wouldn't get from the particle. So, quick example, that's probably what I mean, that doesn't compile, but what a service, like a really quick Hello World application would look like. So you have a function called poll, it makes a request to HTTPS, you get a response. If the status is 200, which means you got a response, you can actually go and say, hey device, I'm sending you an event, there's a duration. So the API between the agent and the device is completely event-driven. Every time the agent needs the device to do something, it needs to go say, device, do this. On the device side, what you do is that you do an agent on, if you look at the last line, on thing happened, then it actually calls a function blink. So there's a big event-driven mechanism, and the device can talk back to the agent as well to go and react to and go and do things on the cloud. So that's how they communicate. It's completely abstracted out from you. It's been reliable from my experience and even spotty connections. So think about it that way. When I do the device code, it actually just runs there. The rest just runs in a 1 megabyte virtual executor in the Electric Imp cloud. So it's actually pretty cool when you think about it. It's all taken care of. The other thing is that the agent is 1 megabyte, right? You can't really do a whole lot with it. You're fairly limited, so depending on your project, you might just use it as a pass-through. So how did I actually start building that? Well, the first thing I did was to just connect my phone, just do a very simple iOS application and connect to their cloud and just post a nice message to the Electric Imp cloud, and I got my LED to blink. So if you are starting in IoT, by all means start with that because you'll run into hardware issues. Even doing that, if you don't have any experience with hardware, it's very important that you know that bugs can be physical in this case, not just in text and in code in a file somewhere. But I scrapped that idea. I mean, it's just not good enough. I mean, I need to do more, right? I need to connect my plant. So the next thing I did was to bring in the Twitter APIs in the agent code. There's, you can do that. It works for some projects. It would have worked for this one, to be honest, if I didn't plan to share that with 24 people and show them how to do things. It would have worked, but I'd prefer not doing that overall. For your do-it-yourself projects, it's probably fine, but for a real IoT, real-world IoT project, again, not good enough. I mean, you have a nice piece that's 1 meg, so think about scaling, think about using more and more services. Even if you start collecting data for analytics on the Imp cloud, it's going to grow, the data set's going to grow, and if you want something valuable, you can't keep it to that. So most of the solutions that we've actually built for our customers need an intermediate server somewhere. I'll get back to that later. So basically how it works is that your agent gets the Twitter REST API, and when I tweet to it, the REST API basically looks for mentions, just pulls for mentions every second. And when I get a new mention, I just start blinking my LED, right? So that was my first pass. Then I added my REST APIs as well. For more things. So I added my hygrometer to it, I added my photoresistor to it, I added a button to it, but I still did everything in the agent. It works. Like I said earlier, it works, it's fine, it's perfectly fine. If you're actually building like a smart garage door opener, a smart, for fun, a smart alarm clock, a smart anything you think of that could be, running off a breadboard, this is really good enough. But really what you really need to do if you're thinking a bit higher is you need to bring a node server or a server somewhere on the cloud to interact with it. of it that way. If I even had more than one plant, I need to manage these plants somewhere. So we made a node server. The node server also allows us to offset some of the logic to the cloud. The big thing is that firmware is expensive. Firmware is risky to update. Even if it's the Electrical Imp, they have good support for their devices, but still you want to offset risk somewhere else as much as you can, and you want a server in the meantime to do that. So what I actually did, I broke the server in a couple layers. One of the things I actually did is I actually brought the hardware abstraction layer, because it's simple, in the server. So as opposed to the cloud. The reason behind that is I was trying to think a bit further out. What if we had two versions of this device? What if we had a Raspberry Pi version? What if we had a Google Brilio version of this thing with a completely different hardware? I might not get the same readings based on the hardware we're getting. What if I connect it to a different plant or a plant that's completely in the sunshine all day? I might not get the same information there. The server would have that information, and like I said, because the Electric Imp is so limited, it really shouldn't be concerned about this. So what I actually did is give the server the raw sensor values being in 16, so you know, from 0 to 65,000 something, and do the translation on the server directly. So if I actually need to change something, I just go on Node. It alleviates some of the problems that we talked about earlier with collaboration. If I have a nice repo with Node in there, we can collaborate. It doesn't break everyone. Everyone's on the same page. So I brought that in there for now. As tools mature, I'm sure there'll be a good reason to bring it back, to put it on the actual devices, but right now I didn't feel that they were quite ready. That said, you should still do hardware abstraction layers on your devices from time to time. Your phone has it, your computer has it, they all have it, but for the simple purpose of this exercise, it answered our needs a lot better. And then I had an analytics layer to capture all the data from all the plants. So we had up to 30 plants connected on this at some point in time, and it gathered a lot of data. That's where it'll need to stay, right? It can't live on your Electric Imp. It just, 1 megabyte of memory is not big enough. If you think of building a real product with that, you need that data to persist somewhere else. So that's why I put that there. And the social layer as well. So that I put the Twitter API there. There's a nice Node.js API for it as well. You don't get that richness of APIs on the particle or all on the cloud platform. So you have to implement your own HTTP requests in that case. So that's kind of it in a nutshell. You can follow it on Twitter. You can go and ask it questions. It's pretty much always alive somehow. But hopefully this gives you a good idea of what it takes to start an IoT project. They're a lot of fun, to be honest. I mean, they're nice, small things that you can go and connect to the internet. It's just another data point that you can play with. If you actually think of having a project that's using lots of data, just put some sensors somewhere on an IoT device and just gather data every second. You'll get a decent sized data set fairly soon. So thanks for being here, and hope it gives you some insight on how IoT works.